Hello class. Today we're going to look at the next step in evaluating expressions. Okay, so just be prepared for that. Now I got a couple warm-up questions I'd like for you to do first before we actually get into our lesson. So what I'd like for you to do is pause the video and answer this question. Okay, so let's see how you did. Now, this particular question is a former STAR question. It's one of the ways that we test whether or not you understand the idea of equations and evaluating expressions, because really what you do is you plug in values in this problem to see if it works. Okay, is all you're really going to do, because you're really not going to solve it. So in this one right here, it says, what value of x makes the equation true? So we have x divided by 3 minus 3 is equal to x divided by 9 plus 3. Okay, so what we need to do is we need to look at values that if I were to divide by 3 or divide by 9, I would get a nice number. Okay? So when we look over at the first one, if we were to look at f, this one will work just fine, but the second one will not. Okay, so I'm not going to use one of those values, but I could use this negative 9. Okay, because I know if I divide it by 3, I'll get a nice number. If I divide negative 9 by 9, I'll get a nice number. So let's try that one and see which one works. So really, I'm looking at G and J just with common sense. Okay, so I'm going to do negative 9 divided by 3 minus 3 is equal to negative 9 divided by 9 plus 3. Now, I'm not using a calculator. I'm just kind of doing this by hand. So we got negative 9 divided by 3 gives me negative 3 minus 3, which is really plus negative 3, which gives me a negative 6. So on this side, I've got negative 9 divided by 9, which is going to give me a negative 1, plus 3. Negative 1 plus 3 gives me 2. Is negative 6 equal to 2? No, it is not. So that is not a correct answer. So the only other answer, the only other one of these numbers that actually makes any sense is going to be J. So let's take a look at that one. So we got 27 divided by 3 minus 3 is equal to 27 divided by 9 plus 3. Well, 27 divided by 3 is going to give me 9, and 9 minus 3 gives me 6. Okay, so on this side, I got 27 divided by 9, which gives me 3, plus 3. So does 6 equal 6? Yes, it does. So J is my correct answer. And what I did using a little common sense, I knew that the only two answers that would be divided by 3 or divided by 9 with nice numbers would have been either negative 9 or 27. And then you just plug those in to see if they work. So what you would do is plug this into the calculator, plug this into the calculator, and see if the answers are the same. Okay, I got one more question I'd like for you to do before we begin our lesson today. So pause the video, read this question, and come up with an answer for me, please. Okay, so let's find out how you did. So this one says the mass of a textbook is approximately 0.00165 metric ton. How is this number written in scientific notation? Okay, so if we were to look at this, we know scientific notation, we can first come down here and look which one of these numbers is actually written in correct scientific notation. So we know that correct scientific notation is going to be a number, a decimal, and then any other numbers that I would need other than zeros times 10 to the, and because this is a small number, we know it's going to be a negative exponent. So that's the format that I'm looking for. So I look at this one right here. I know this first number here is going to be wrong because it's got to be a value between 1 and 10. Okay, so G, that one does have a value between 1 and 10, so it looks okay. H, it doesn't because it doesn't have the right value. And J doesn't. So the only one by common sense, just knowing format, that would work is G. Okay, and that's what we are looking for in scientific notation. Okay, any questions? Excellent. Okay, so let's move on. Today we are talking about graphing, so let's kind of review the parts of a graph real quick. Okay, so if we remember correctly, this little point right here, it has a location of 0, 0, and we call that the origin because everything originates from that spot. Okay, now we also know that this line right here, this horizontal line going across, is called the x-axis, and the vertical line is called the y-axis. Okay, now we just have to locate points. Okay, so if we were to look at this point right here, it is at positive 3, and then 1, 2, 3, 4, 5, 6, 7. So we know that's going to be 3, 7. And we know this one's going to be 1, 2, 3, 4, 5, but it's left 5, so that's a negative 5. And then up 1, 2, 3, 4, 5. So negative 5, 5. Now, we do know that this graph is divided into 4 sections. And we know that this section is called quadrant 1. The one to the left is quadrant 2. Then quadrant 3. And then quadrant 4. Okay, so it just makes a C when we're talking about quadrants. And we know that this top quadrant is always going to be points that are positive, positive. We know that quadrant 2 is going to be X values are going to be negative, but your Y values are going to be positive. Okay, in quadrant 3, they're going to be negative, negative. And then quadrant 4, they're going to be positive, negative. And that's what the types of points will look like. We're going to need that today. Okay, so the standard that we're still working on is 7.7a. We're going to represent linear relationships using verbal descriptions. Well, that was the reading and writing expressions. Okay, we're going to look at tables, which we call T-charts. Well, today we're going to look at graphs. Okay, how are those three connected to each other is what we're trying to look for today. So far, this is what we've done. It says we've evaluated expressions where I give you the values of the variables and I change the expression. So I give you the instructions, X is equal to this, Y is equal to this, Z is equal to this, and then I give you a bunch of expressions to use. That's what we've done so far. Okay. Another thing that we did, okay, is I gave you one expression and I had you evaluate that for multiple values. Okay, and then I changed the value of the variable. Okay, so this is where we did our T-chart, where I'd give you one expression and I'd give you multiple X values to evaluate it for. Okay, and then what did we use to organize that? We used that T-chart that I just got through talking about. Okay, so we used a T-chart to do that. Well, today we get to find out why we organize data in a T-chart. So let's see if we can do one. Please write this T-chart down on your paper. I'll give you a few moments to do that. Okay, now this one was one that we did on our homework assignment just the other day. Okay, so we know that this says if X is negative 2, then X plus 4 is what? Okay, so we know that that's what it says. And what I had you do is I had you show the work on the first 3 X values. Okay, so I'm still going to make you do that. So in this first one here, X is negative 2, so we do negative 2 plus 4, and we would end up with positive 2. Then I'd plug the negative 1 in. Negative 1 plus 4 gives me 3. And then 0 plus 4 gives me 4. And then we could use the pattern for the rest of those. So the pattern is counting by 1. So the next one is 5 and then 6. Now, what I need you to understand is that these values here are our X values. They represent our independent variable. Okay? Now, when we look at a graph, did I have a axis that was called the x-axis? Yes, I did. Well, what was the other axis called? The other one was called the y-axis. Well, this represents x, and this on this side, believe it or not, it represents y. So what you're really doing when you create a T-chart is you're creating a set of coordinates for a graph or for a picture. So out on your paper, what I'd like for you to do right beside where you did that T-chart, I want you to draw me a y-axis, and I want you to draw me an x-axis. Doesn't have to be perfect. Just draw it something like that right there. Okay, and then what I want you to do, I want you to put 3 tick marks going to the right, 3 tick marks going to the left, 6 tick marks going up, and 2 tick marks going down. That's all we had to do. This is going to be kind of like a little quick graph of what we're doing. We only put the tick marks that I need. Now in your assignment, I'll give you a graph, so it makes it a lot easier. Okay, so what we've got here is we've got this point right here. It's negative 2, 2. Well, that's a coordinate, and that says I'm going to go from this origin, I'm going to go left 2, up 2, and I'm going to put a dot. Okay, then the next one says I'm going to go left 1, up 3. So left 1, up 3, put a dot. The next one says I'm going to go right or left none, go up 4. And you'll notice that those look like they appear to be on a line almost. Okay, well, let's keep going. Well, 1, 5 says I'm going to go right 1, up 5. And then the last one here says I'm going to go right 2, up 6. Okay, so it does kind of appear that they're on a line. But is it really? Okay, well, here's where we got to kind of think about this graph. Okay, on this graph here, I graphed those points right there. But let me ask you, between this 0 and 1, are there any other points? Could I have maybe a 0.5 there? Or could I have maybe a 0.25 in between the 0 and the 5? I could have those, and I would have a corresponding y value for each one of those. So that means really between this point right here and this point right here, there's actually a whole bunch of points in between. Matter of fact, there's an infinite number of points in between. What that means, if I were to actually graph the entire graph, if I were to graph all of these points in between, it would like make a line. Well, in between these 2 points, it also has an infinite number of points. In between these 2 points, it has an infinite number of points. In between these two, it has an infinite number of points. So really, in essence, that kind of represents the points that I've done there. But let me ask you this. Could I also have maybe a 3 for an x value? Or a 4? Or maybe a -3? Yes, I could. Okay, matter of fact, those numbers could go on infinitely in both directions. So the way we represent that on our graph is we connect the dots, we extend out past, put an arrow, we extend out past, put an arrow the other direction. And that is the picture of what x plus 4 looks like. Now here's the thing. There's not any other expressions that look exactly like x plus 4. That is the only one that will look that way. And that's the reason why we fill out or evaluate an expression using the T-chart, because that T-chart then gives us points that can tell us what its picture looks like. Okay, so we can use a verbal description of this, saying that this is x plus 4. I can collect data using this by using a table to evaluate that expression. And then now I can take that expression and put it on a graph, which shows us its picture, which tells us the 3 things that we're looking for: the verbal description, the table, and the graph. Okay, and that's what we're looking for today. Okay, that's the reason why we organize our data in a T-chart, is because it makes a set of coordinates. So let's do another one. Here you go. Please write this one down. So copy that T-chart down. I'll give you a few moments to do that in your notes. Okay, so let's find out how we do this one. Okay, so again, we know that this says if x is -2, then 2x, or 2 times x, is what? Okay, so we know that 2x means I'm going to multiply. So that means I'm going to do 2 times whatever the x is, which in this case is -2, which would give me a -4. And then 2 times -1 would give me a -2. And then 2 times 0 would give me a 0. And then what am I doing? I'm increasing by 2, so this one's going to be a 2, and this one's going to be a 4. So I increased by 2 each time. And now, what we did was we created a set of coordinates. This first number is our x, the second number is our y. So that means on this graph, and for you, I want you to draw me another graph. Okay, and on this particular one, okay, draw the little graph like this right here. To determine the number of tick marks that you need in your T-chart, we look at our numbers here. Our x's goes from 2 to -2. So I'm going to put 2 tick marks and 2 tick marks. And here I've got -4 to +4, so that means I need 4 going down and 4 going up to accommodate the points that we have on our graph. Okay, so -2, -4, put a dot. -1, -2, put a dot. 0, 0 is our origin, so it goes right through that origin. And then 1, 2, right 1 up 2, and then right 2 up 4. And now to finish this graph out, you play connect the dots, extend out past in one direction, and extend out past in the other direction. And that's how you do the graphs. Now, does that look about right? Okay, now, if we were to look back at this other one, how is that one different from this one? Well, this one looks a little steeper. Okay, we're going to find out that this number right here has something to do with its steepness. Okay? Now, the other number's got something to do with it also, and we'll talk more about that next week. Okay, but let's look at one more. One more. Let's don't do that one. Let's go ahead and do this one. That's fine. We'll do this one, then we'll do one more. Okay, so the first thing I would do on this one, if I'm doing this one, is I'm going to change my subtraction to addition next to its opposite. And then I'm going to evaluate. Okay, so we know this one's going to say 3 times -2 plus -3. So we do our math. 3 times -2 gives me -6. Negative 6 plus negative 3 gives me negative 9. Then I got 3 times negative 1 plus negative 3. Well, 3 times negative 1 gives me negative 3, plus negative 3 gives me negative 6. And then 3 times 0 plus negative 3. Well, 3 times 0 is 0, plus negative 3 gives me negative 3. And then 3 times 1 plus negative 3. You didn't have to show the work on that one, but what are we actually doing here? We're counting by 3s. We're increasing by 3. So if I did this one, 3 times 1 is 3 plus negative 3 gives me that 0. And then if I do one more, I get 3. So if you're going to do a quick graph on this one, I've got to have 2 to the left, 2 to the right, 9 going down, and 3 going up. Okay, so here's what this graph would look like. Okay, so we got negative 2, negative 9, which would go right there, and I know this has got 10 lines to it. So then negative 1, negative 6, and then 0, negative 3, 1, 0, and then 2, 3. Okay, and then to finish this out, we play connect the dots. Okay. And this one was really steep. Okay, and you'll notice that I had a number 3 right here, which made it even steeper. Okay, by comparison to the other two. This one was a 2, not quite as steep. This one was a 1, not quite as steep. Okay, so what happens if I give you something like this? Okay, so in this one right here, it's got negative 2 times x. So that you think that negative will have something to do with it? Maybe, let's see. So it's going to be negative 2 times negative 2, which gives me 4. Then negative 2 times negative 1, which gives me 2. Negative 2 times 0, which gives me 0. So what am I doing? I'm decreasing by 2, so the next one would be negative 2 and then negative 4. And then we graph. Okay, so in this one, to graph it, that means I'm going to go left 2, but up 4, which goes right there. And then the next one is left 1, up 2, and then on the origin, and then right 1, down 2, and then right 2, down 4. Okay, so what happened with this one? What did that negative do? Well, now instead of going uphill, it's doing what? It's going downhill. So if my numbers are decreasing, my graph's going to go downhill. If my numbers were increasing, my graph went uphill. Okay, so as you read that graph, that's what we're talking about. So what you're going to do in your assignment today is I'm going to give you 6 of these to do. Okay, so the first one looks something like this right here, where I'm going to give you a T-chart. I'm going to have you evaluate it. Yes, you need to show the work for the first 3 X values. And then you take these points with whatever you have here, you graph it, you connect the dots and extend out past on both directions and put arrows on the end. And that's what I'm going to have you do. So you're going to do one there. Oh, let's see. I skipped a few. There's number 2. There's number 3. There's number 4. There's number 5. And then there's number 6. Okay, so this one, be very careful with. Okay, so that's your assignment, and that's what we're doing today. We're talking about how to graph expressions, because that's what our standard told us to do. Be able to do a verbal description, be able to collect some data on that expression, and now we are graphing it. Okay, so until tomorrow, I'll see you later.